Alright, so last topic on linear inequalities is how to graph a linear inequality. We're not talking about the number line graphs you've done in middle school or elementary school. We're talking about an actual line involving two variables, like y equals mx plus b kind of stuff. So the process for finding the 2 points to make your linear graph is the exact same process when you did the equations. If it's in y equals mx plus b form, you plot your y-intercept, and you plot the second value using slope. If it's in standard form, the ax plus 2y, you set the ax equal to the constant, the by equal to the constant, solve for your x and y intercepts. There are two differences though. They lie in how you connect the 2 points and how you shade in the proper region, because inequalities, we no longer have just a solution. For example, if x equals 4, that is the only possibility for x. It has to equal 4. But if x is less than 4, there's a wide range of possibilities that could work for x. So that's why there's going to be a shaded region for your linear inequality graphs. And connecting the 2 points, again, depends upon whether we're including the 4 or not. So your 2 points will be connected by either a dashed or a solid line. The line is going to be dashed if the inequality is just less than or just greater than. You will draw a solid line if the inequality is less than or equal to or greater than or equal to. The reason why it's dashed is because technically all the points on that line are technically not solutions to that inequality. We use the points in the dashes to help create the line itself, but they don't actually represent real solutions. But when we have less than or equal to or greater than or equal to, the points on the line are solutions to that inequality. That's why we're allowed to have it fully filled in. Now, after we connect our points, we need to figure out which region we shade in, which one represents the actual solutions for this set. The easiest way to do this is to plug in the origin point, 0, 0. X equals 0, y equals 0 into the original equation to see if you have a true or false statement. If your statement is true, the region you'll shade in will include the origin. If your statement is false, you'll shade in the opposite region. And I'll show you what that means in a little bit. So we want to graph this function. Y is less than 3/4 of x plus 2. So first thing we do is we're going to plot the 2 on our y-axis. We're going to use our slope as 3/4 to go up 3 to the right 4. So that process is the exact same from equations. Now, because it's just less than, we are going to connect our 2 dots with a dotted line. It will not be solid because it's not equal to. Obviously, if you're doing this by hand, I'd recommend a ruler to make that line look a little straight. I can't really use a ruler with my writing tablet. Now, we need to plug in 0, 0 for x and y to see if we have a true statement, to see if this origin point right here is in the shaded region or if it's not. So 0 less than 3/4 times 0 plus 2, we get 0 less than 2, and that's true. Because it's true, this is the region that we're going to shade in. You can shade in however you like. I just recommend just simple lines that are perpendicular to your line that creates the graph. You'll see why when we talk about graphing systems of linear inequalities next chapter. So again, this is the region we shade in, this portion right here, because this area in here includes the origin point, which we found by plugging in as a true statement. If you plugged in any other point that was not in that region, like for example, if you plugged in -4 for x and 0 for y, you would have gone -3 plus 2 is -1, and 0 is not less than -1, so that's why you know it's not a point. The origin is easiest because the x and y's go away, leaving you just nice numbers. So let's try this one. Y is greater than or equal to -5/3 of x plus 4. So again, we'll plot our y-intercept, the 4. Our slope is -5/3, so we go down 5 to the right 3. Now, because it's greater than or equal to, I can connect the dots with a solid line. So now I want to know, is my origin in the shaded region or is it not? We plug in 0 for y and 0 for x. We're going to get 0 greater than or equal to 4, which is false. 0 is not bigger than 4. So because it's false, this region in here that includes the origin cannot be the shaded region. It has to be the opposite region. And that's what I mean by true using the origin region, false using the opposite region. That's what we mean. So again, if your inequalities are in slope-intercept form, you plot your y-intercept the exact same way, this number right here. Use your slope to get to the second points. We now have our two differences. You connect the dots with a solid line if it's equal to, dashed line if it's just, there's no equal to portion to it. You then plug in the origin, 0, 0 for x and y to see if you have a true statement. And if it's true, we shade in that region. If it's false, we shade in the opposite region. So let's do the same thing for our standard form. So our standard form, we're going to set our x components, 4x equal to negative 24. So x equals negative 6. Define our x-intercept. We set our y component, negative 6y equals to negative 24. So y is positive 4. Define our y-intercept. Because it has an equal to, we're going to connect our dots with a solid line. Okay, let me actually connect those dots with a solid line. Let's try it again. And there we go. So now we're going to plug in 0, 0 for x and y to see if we have a true or false statement, meaning do we have the origin as our point. So we get 0 less than or equal to negative 24, and that's false. 0 is not less than a negative number. Since this is false, we cannot include the origin in the region, so this region is not the shaded region, it's the opposite one. Okay, so one more. So why don't you go ahead and graph this one on your own, find your 2 points, connect the dots appropriately, either dashed or solid line, and determine whether you have a true or false statement, meaning do you include the origin in your shaded region, or is it on the opposite side? So go ahead and pause while you work that out. Okay, so you should find your x and y intercepts to be negative 4 for x, negative 6 for y. Your line is going to be a dashed line because we have just greater than, there's no equal to piece. When we plug in 0 for x and y, we get 0 greater than negative 12, which is true. So we include the origin in our shaded region. That's why this area right here is what's shaded in. Okay, and that's how you graph your linear inequalities. Again, begin the process the exact same way. Just make sure you connect the dots appropriately, and you don't forget to shade in your appropriate region. So that's it for chapter 6. Chapter 5. Next, chapter 6, we're going to discuss how to solve systems of equations. So I will see you next time.